Okay, so this is the first lesson of our remote learning. This is about linear regression, and we did go over linear regression in class, but I just wanted to review this one, and we'll review the correlation coefficient, and then we'll go on to the next thing, which is residual plots. So for linear regression, this requires us to have a graphing calculator of some kind, and I know that many of you don't have a TI Inspire, so we are going to use Desmos, which is just on the computer. And if you have an Apple device or a smartphone, you can download the Desmos graphing calculator app. And it looks like this. And this is what it looks like on a computer as well. So you just go to desmos.com and you go to the graphing calculator. And that's what we want to do today. So I'm going to split screen this. Like this. So the worksheet is on the left, the Desmos is on the right. And we're just going to go through these two example problems on this linear regression worksheet. And then on your assignment, you'll have to do this on your own. So on Desmos, the first thing that we want to do is make a scatter plot of the data. So on this problem, it says a convenience store manager notices the sales of soft drinks are higher on hotter days, so he assembles the data in a table. And then A says make a scatter plot of the data. So we're going to do that on Desmos. So over here, there's this plus sign, and we want to include a table. And what we'll do is we'll have the temperature is X, and the number of cans sold will be Y. So then on Desmos, we're going to type in those values. So the first X value is 55. Then we have 58, 64, 68, 70, 75, 80, and then 84. And those are all of our high temperatures. And then the other column is number of cans sold. So we have 340, 335, 410, 460, 450, 610, 735, and 780. So now if you notice over here on our graph, they're not showing up, and that's because we aren't looking in the right place. So I'm going to zoom out a little bit until we start to see points. And then you can see our points right here. And I'm going to change the scale here. So this is our data. That's the scatter plot. So we've done the first one. So I'm going to put a little check there next to A. And then it says find and graph a linear regression model or a linear regression equation that models the data. So the way we do this on Desmos is the equation for a line, if you remember, is y equals mx plus b. So that's what we're going to type in. But instead of just having y, we're going to name it y1 because in our table up here, right here, it's named y1. So we're going to say y1 equals x1 plus b. Plus b. Oh, I made a mistake. We have to do the little squiggle because it's saying that it's approximately equal to, right? We have this little squiggle line. It's called a tilde. And that says that we want our line that fits those points the best. So that's how we do our linear regression. So our equation here is going to be y equals, and then if you look down here, it says parameters on this side with the graph, it says parameters. So right here, it has m equals 16.4163. So we're just going to abbreviate that to 16.4. Then we have x, and our b is negative 621.8. So that's what our linear regression equation is going to be. Okay, so the next part says, use the model to predict soft drink sales if the temperature is 95 degrees. So the temperature, that tells us the x. So in our equation, we're going to plug in x is 95. We're going to plug in 95 there. So we have y equals 16.4 times 95 minus 621.8. So on here, I also have the scientific calculator for Desmos, so I'm going to bring that one up as well. So I'm just going to type this in. I have 16.4 times 95, not 35, 95 minus 621.8. So that tells us that when the temperature is 95 degrees outside, that approximately 936.2 cans of soda would be sold that day. And that makes sense to me because if we look at our table over here, as the temperature gets higher, the number of cans sold also gets higher. And that's because when it's hot outside, people want a nice ice cold drink. And so if we put 95 down here, our data would make sense that it would be about 936 cans sold. The last question, I'm going to put my scatter plot back over here. The last question says, using the scatter plot, describe the association you see between the two variables. So based on this scatter plot over on the right side, how would you describe the direction? Is this a positive or a negative slope? And since it's going up, I would say that this has a positive slope. And then we've also talked about the strength, whether it's strong, weak, moderate, perfect. We've talked about those. So on this one, the points are pretty close to our line. So I would say that this is a strong, positive correlation. And that's what I would say for this data. And we're not going to fill in this graph down here because we already did it on the calculator. And that is our first example. So you're going to have to do something similar to this on your homework. So we're going to go through one more example, which is this one. And I'm going to close out these points or the table that I already had because we're going to have different data. So I just wanted to clear out the stuff that was already on there. So number 2 says anthropologists use a linear model that relates femur length to height. Now femur length, that's the bone like in your thigh that goes from your hip down to your knee. That's your femur. This model allows anthropologists to determine the height of the individual when only a partial skeleton, including the femur, is found. In this problem, we will find the model by analyzing the data on the femur height or femur length and height for 10 males given in the table. So basically what this is saying is if a scientist found your femur, then they would be able to predict how tall you are based on this data. So let's go back into Desmos. We're going to add a table and I'm going to type in this data. So our first one, we're going to have the femur length, that's going to be X, and then the height is going to be Y. So we're going to have 50.1, 48.3, 54 or 55.2, 44.7, 44.5, 42.7, 39.5, and 38. So those are our X's from that column. And then our Y's, we have 178.5, 173.6, 164.8, 168.3, 165, 155. Oh, I think I skipped one. Oh, I did right here. So we have 164.8, and then we have 163.7, and then 168.3, 165, 155.4, and 155. And you don't have to, you could put 155.0 and 165.0 if you wanted to, but it's the same thing if you don't include the 0.0. So now, once again, we don't really see our scatter plot. It's kind of over here, and it looks linear, but I'm going to spread this out so that it kind of spreads out the points too, so that it looks more like what we're looking for. And if you're on like a smart device, like a tablet or your phone, you can just pinch this. Like you just put 2 of your fingers down and you just spread them out to change the scale. And you can do that on either one. So you can zoom in, you could make the X bigger or smaller, and you can make the Y bigger or smaller. So I'm gonna leave it like that. And then we want to add in our equation. So remember, it's y equals mx plus b, but we have to change it a little bit for it to be a regression. We're gonna put y1, and then we need to put the tilde because that tells us that it's not an exact equation. We're approximating where the middle of that data is. So we have y1 and then the tilde mx1 plus b. And once again, that brings up that r value. And if you remember right here under statistics, we have r squared, which we haven't learned about that yet, but the r value, that tells us our correlation. So that's the correlation coefficient. And then right here, we have our m and the b for our equation. So over here on the worksheet, I'm gonna put y equals m, we have 1.9, and it's 0.9231, but I'm just gonna approximate it to 1.9. So 1.9x plus 80.7. And the reason why we have 0.7 is because it's 0.68, so the 8 makes the 7, or makes the 6 go up to a 7. So that is our regression equation. So on C, this says an anthropologist finds a femur length of 58 centimeters. How tall was the person? I'm going to slide this over so that we can see it a little better. So on here, we know that the femur length, that is right here. So that's our x value. So that means that x is going to be 58 centimeters. So we're going to take that x value and we're going to plug it into our equation. So we have y equals 1.9 times x, but we know x is 58. And then we have plus 80.7. And just like I did last time, I'm going to open up the scientific Desmos. It's just like a normal calculator where you can put in parentheses and stuff. So we have 1.9 times 58 plus 80.7. So that tells us that a man whose femur is 58 centimeters, the regression equation, or our prediction, would be that he would be 190.9 centimeters tall. That would be his height. So the last question, I'm going to bring up our scatter plot again, and I'll slide this over a little bit. So on this one, I would also say is a strong positive correlation. Because the slope is going up. So if you have a slope going up like this would be positive. And then what a negative slope would look like is if you had a line going down. This would be negative. So we know that the one in our example with the femurs and the height, this is a positive correlation. And it's a strong correlation because the points are pretty close to the line. So it's something like this. The points are really close, so it's a strong correlation. But if it was more spread out, like if we had points all the way over here, you know, like this would be a weak correlation because the points are more spread out from the line. So that's the difference. And we'll review that again in the next lesson. So don't worry if you don't quite remember that. But on your homework, you're going to have to take a table like this, find the regression equation, and then interpret, like plug in something for x and find this. Okay? And if you have questions, you can get on Zoom and from 11 to 1, and I can help you with the assignment, or if you have a question about the work that we did in this video. Okay, good luck.